Hi, I'm Eric, and I'm here to talk about what seems like kind of an absurd idea, that if then else had to be invented. If then else is how we talk about conditions in programming languages. If something is true, then do a thing, else do a different thing. That's just English, right? Except that it isn't. I can't use else as a conjunction in normal speech, only in programming languages. So where did this else come from? It's too microscopic a detail to have made it into any books on the history of programming languages. It doesn't seem to have come from any of these sort of pre-computer sources, surveys or legal proceedings or algorithms, as they were written before there were computers. You find if yes and if no and if however, but not else. The first computer to be able to perform different instructions depending on the result of a previous calculation seems to have been the Eniac. In 1946, Haskell, Curry, and WILLA WYATT wrote this report describing a program to invert a function. They used the name discrimination for the facility of making a decision based on which of two numbers was larger. The Eniac didn't have an instruction called discriminate, though. It was programmed by wires and dials on plug boards, and the control panel for the instruction that made a calculation for a decision was connected by physical wires to the instructions that could follow it. But soon computers began to have enough memory that programs could be stored in memory rather than wired together. Instead of a physical sequence of instructions, there was a numerical sequence, and a few special instructions could cause the computer to jump to a different point in the sequence. Here, for example, is the conditional jump instruction from one of the first commercially produced computers in 1949. It checked whether the last number calculated was negative, and if so, it diverted the flow of control to some specified location in memory. Otherwise, it let control continue to the next instruction. This was meant for a specific usage pattern. If you wanted to do a task, say, 10 times, your program counted how many times it had done it so far, and then subtracted 10. If the result was negative, the task wasn't done yet, so it jumped back to do another round. This idea was carried forward into the first higher-level programming languages, like Halcombe Lanning and Niels Erler's language for Whirlwind. Their conditional jump instruction worked the same way, except that the numbered steps of the program were algebraic expressions, not single machine instructions. The first really popular programming language, Fortran, generalized this idea by specifying jumps to 3 locations at once, depending on whether a calculation was negative, 0, or positive, and gave it the name if. The three-way if was arguably more powerful than just checking for negative, but was probably more confusing because it meant that every decision caused a discontinuity in the control flow, instead of programmers only having to think about the normal case that continued on and the unusual case that jumped. Flowmatic, which was Grace Murray Hopper's predecessor to COBOL, made the three-way if a little easier to think about by talking about comparing two numbers rather than about the signs of numbers. And it also introduced the name otherwise for the case where the comparison wasn't what you were looking for, which is sort of heading in the direction of else. All of these programming languages were associated with one particular computer from one particular manufacturer. But in 1958, 2 American and German computing organizations began a joint project to develop a standard machine-independent language, one where it would be natural for people to talk about rather than natural to implement on some particular machine. Each of these groups brought a draft proposal to their joint conference. The German authors made 2 big conceptual leaps in their reformulation of the if statement. The first was to let the conditional be controlled by any Boolean expression, rather than giving special priority to the less than, equal, greater than form. The second big leap was that instead of causing an abrupt jump in the control flow, their if statement only caused the flow to be temporarily diverted. At the end of the condition, whether the condition had been true or false, the program would resume at the always statement at the end of the block. The only difference would be whether or not the subsidiary statements had been performed. The example on the screen shows 2 ifs as part of a single block, and you might think that the second one was intended to work as an else if does now. But they actually expected all the conditions to be evaluated, even if one of them had already been found to be true. So if the statements controlled by the first changed the value that the second comparison depended upon, both blocks of statements might execute. Where the German proposal did have something like else was in a second, entirely different conditional form called case. Unlike case as we now know it, their case was another way of writing Boolean expressions, but with the statements set apart in a separate block from the statements they controlled. It sounded like they thought this form would be easier for more complicated comparisons. And here is the first appearance of the word else, for the case where none of the other cases apply. Why did they call it else? They don't say. What they do say was that this document was originally written in German and hastily translated into English. And so So I think that a carefully chosen German word was probably translated as an archaic English word and then never revisited. Unfortunately, we don't have the original German text to consult. The American proposal also had the idea of controlling statements by Boolean expressions. It didn't even have an if keyword. Instead, if an expression was followed by an arrow, the expression controlled the statements that followed the arrow. The notation doesn't make it obvious, but unlike the German block of ifs, in the American form, if one expression in a block evaluated to true, it did short circuit and skip the following expressions, like else if does now. The two organizations held a joint meeting and merged their proposal into a single document that they called the International Algebraic Language. Before long, the language would be renamed to Algol. The if statement in the combined document looks a lot like the German proposal, but it eliminates the always statement to end the block. Instead, each if stands alone, and if you want multiple statements to be controlled by the same expression, you can use begin and end to group them together. There's nothing like else in this formulation of if. However, Algol 58 also had a second conditional form called if either. In this form, you could say or if to do the same thing that we now do with else if, but there's nothing equivalent to else by itself without another if. The story gets really muddy the next year when several papers about Algol were presented at a conference. One of them was the paper where John Backus, who had previously led the Fortran project, introduced the idea of formal grammars for programming languages. Algol, in his description of it, doesn't have the if-either conditional form. Instead, it has a keyword called converge, which makes the top-level ifs inside its block behave like else ifs. It's not clear whether this was meant as an idea for a better if-either, or whether it was an earlier idea that had actually already been rejected in favor of if-either. Either way, if-either would soon be replaced. In 1957, John McCarthy at MIT had written a proposal for the project that became Lisp, another extremely old programming language that still survives today. His proposal introduced the idea of the conditional expression as opposed to the conditional statement. The important distinction is that an expression must always have a value, while a statement can simply not be performed if the condition that it controls is true. So his if function always ends with a clause called otherwise that gives the value of the expression when none of the other conditions evaluated to true. And finally, McCarthy's conditional expressions inspired Klaus Samuelson to clean up and unify Algol's two separate conditional models at the end of 1959. He eliminated the entire if-either form, leaving only the plain if, but added a clause called else that would be performed when the expression controlling the corresponding if had been false. You could chain conditions together with else if, just like the previous if-either had allowed with or if, but you could also use else by itself for a final set of statements that would run if none of the conditions had been true. If then else was the single conditional form that then appeared in the Algol 60 report the next year, and is the form that almost all subsequent programming languages have followed. Although it seems clear to us now, it was hard for people in 1960 to think about, and the report spends a page and a half explaining how it works, including this arrow diagram. As I mentioned before, the use of else as a conjunction sounds strange. Christopher Strachey's CPL programming language is the grandparent of C and therefore the ancestor of most current programming languages, and he refused to use else, calling it ignorantly incorrect English. He thought we should write test then or instead, which doesn't sound very natural and didn't catch on. The MAD programming language also went its own way. It was known for its extremely long keywords. And in addition to using whenever instead of if, it used otherwise instead of else and whenever instead of else if. It is worth noting in the indentation in the MAD manual's example. It took years before most other programming languages adopted this style of indenting conditions, even though it now seems unimaginable to do it any other way. But even while CPL and MAD shunned the word else, they kept the form and only changed the vocabulary. Language designers still search for the perfect way to write a for loop, but the quest for the perfect conditional form seems to have ended in 1959. Thank you, Klaus Samuelson, for giving us a tool to think with and a word to puzzle over. And thank you all for listening.